Greeting catchphrase name here. What we're doing time of day is. So today we are talking about simple-img. And as we all know what the word simple, the definition of simple is hiding infinite complexity for something that isn't actually simple so that you can use it simply. Right? That's all it is. So what we can see from this demonstration is an input field that has poor timing as far as rebuilding it. But if you change any value in here or you paste in your own image, you'll see it renders the image. All right. I can say height is 260, 700, and we can reduce the quality. Cool. What the heck is going on? So copy this. Let's do a different demo, which is also found in here. If you search for simple, right, there's two simple images come up. One is under microfrontends, we get core services, simple image remixer, which is what you just saw, and then basic example, which is you have to know what you're doing a little bit. So this, we're going to use the knob. So I'm going to throw in an SRC of a wonderful SpongeBob meme. Shows up there. Let's inspect and see what's happening. So let's refresh the page with nothing. Inspect. We see we have a simple img tag, unknown SRC, couple default values. All right, let's update that SRC. And we see we actually get a lot of content rebuilt. We no longer have an undefined or just empty simple img tag. It actually has contents in it. And inside of it is now generated a img tag. So we have the img tag sitting here. There we go. It's 300 by 200. Where did that come from? Well, that came from our hacksapi.vercel.app service that's sitting out there. So if we go, let me say height 500, width 400, rotate 50 or 150, what's happening is our tag is being updated with these different properties. And then those are being reflected. Let's change the quality here to 5. Right? You saw it get like kind of pixelated. We change width to 100. Right? So we're able to manipulate the properties, attributes. I know there's a difference. We map the attributes to properties. So we're able to update the properties of our web component. And then that generates a request to the web service, which puts a new img tag with a different source in that light DOM, and then loads the image in question from the microservice. So we're effectively mapping the API usage of the backend to this nice little front end bridge. Woo! I'll be totally honest, we don't actually need this now. It was mostly to see if it was possible because we will need things of this nature in the future. And the idea of having something that can just sit there and give you back very basic image manipulation is really cool, especially if, let's say, we don't have control over where an image is coming from. It's coming from some other API. Maybe we're getting a user profile image from, in our case, our learning management system. I don't know how big that image is. Might be 300 by 300, which doesn't seem like that much. But if I only need to render it like on the screen, I'd rather have it 25-25, something like that. So even just the ability to hit this and send it out the door, paste a different URL back in, it's also going to be caching those on the way back out. Another fun aspect of this is let's make this 100 by 100. We've got this fun blurry thing. Let's change the quality to 90. Right, so you can see what it is, and we'll rotate it by like 50 so you can still see rotation. Okay, it's really fast, which is also cool. Now, it's giving me a URL the entire time. So if I go and just throw that URL in, voila, right? And this is something I could do 600. We get that happening, right? So it's hitting the endpoint with these different values, and we're doing this manipulation on the fly, and it's very fast after it, gets cached in Vercel's edge network there. So now that I have that URL, which is valid, I can now, let's get rid of this. So we can see, all right, I can watermark that onto the existing image. So I can actually use what was generated to watermark the image itself, which is trippy. And I'll throw this in, and now we have a 500 by 400 edition that is watermarked by our little tiny 100 by 100 edition. And so if I tell this not to rotate, and we make this, let's make this 500 by 400, you'll see we get our nice little watermarking thing in there. I can also send this to the northeast corner if I want, or northwest corner. right? And I could get this back as like a PNG, I think is a valid option. There we go. So what has rendered back across is actually in PNG format, as opposed to JPEG. Not really a reason to do that other than to mess around with the API. Quality, then, we'll make 20. Didn't really seem to reduce it very much now, did it? Ah, that's right, because we're in PNG, we're no longer a JPEG. So it does have value. There we go. It was also fun. I could take the initial quality of that little thumbnail, make it like 9, and then we make the quality of this guy like 60. So we get the blurry sub image. I don't know. It's just fun to do. Anyway, what is powering this thing? Also, there's a code pen sitting out there, so you can actually just tweak these parameters directly with some defaults that are baked in so you can see it in action. I don't want to make that 6,000, but 400 quality is not a thing. 100 quality is, right? And there we go. So we get this higher res image and a watermark that I snagged from 2 URLs you can read there. So what's going on with this one is this seems pretty sophisticated. I've had a lot of issues in the past using different content management systems. Actually, all of them are Drupal. That was a blatant lie. Most of them were Drupal. All of them were PHP based. Grav CMS has the same thing. WordPress, right? You have to configure server tech to interface with a sophisticated monolith. The monolith has image compression and manipulation built into it. And that's awesome until you try to get off the monolith, and now you have to replace this functionality. And it's just yet another pinprick among all the other 1,000 things that you need to put in this monolith. So I thought maybe if we could decouple one of these. So the back end of this, let's start there. Pretty simplistic, to be perfectly honest. There's a really cool package on NPM called Sharp, which is a very efficient way of doing basic image manipulation. So you can see here, we take in as options, SRC, watermark, all the stuff I was messing with, format, watermarking, location, rotation. Do some basic validation. In this case, we read the buffer in, right? So we're fetching the source in question, right? Because I'm supplying this source of an image like that USA Today silly SpongeBob photo, right? So imagine that's what's getting requested. So we're using node fetch for that. Node fetch is going to get the source of that. We're then going to take that source, generate a buffer, and then use Sharp. We pass that buffer object into Sharp, and that's going to give us our image in question. So we've got our image as an object, and now we can start to work with it. Now, if we have a watermark, the fun thing is we actually go and do the same process, basically. We go and request the watermark, make it a buffer, make it its own Sharp image, and then we run a composite function, which requires another buffer and some gravity, which is that location where I'm moving it around, right? You can see I'm mapping southwest to SW in this case. Then for the other options, really straightforward, right? If I want to rotate it, then I run rotate against that amount of rotation. One thing to note is that anything that is numerically valued, right, I did have to parse int these, right? So when they're sent across via URL, it is just a string. It's not 10, it's not number 10, it's string 10. So I have to parse int it to make it into the number 10. Then we take into account resizing. If you only supply a width or height, we account for those independently. If you send both, you can do a fit parameter, which is in the documentation we'll go into. That's like cover versus whether it keeps the whole thing contained. And then we do format changes, and then we issue our standard response. Really simple stuff here, to be perfectly honest. Now, in this case, when we send our buffer back, this is different than our normal standard response, right? I'm actually saying, hey, make the output of type image JPEG. Now, that kind of messes with the whole notion of, like make it a PNG. I didn't rectify that difference because, again, this is at least somewhat kind of a proof of concept to illustrate one web component equals one web service equals reusable thing. So this may tweak over time. But looking at the front end piece then, we have a vanilla web component here, and we pull in the registry just so we can enable core services. Now, one of the services in our core services is this image manipulation endpoint, right? Which we're going to reference as @core image manipulate. We might only ever use this with simple-img, but I wanted to engineer it in such a way that if we need to hit this endpoint for other things, that we could very easily do that. And I think we definitely will have use cases where we're making a microservice that wants to go and get a derivative image from another microservice, in this case ours. So looking at how simple-img works, we just see if there's an image in the light DOM, which is this query selector. If there is, we're looking for a template tag. Now, the reason we might do this, and you can see it illustrated here, there's two different ways to invoke the API. One is just through attributes, and we set these attributes, it goes and generates the thing. The other is through a series of attributes and actually putting light DOM code or HTML in here. Now, if you're not familiar with a template tag is a special HTML tag that tells it not to render on the page. It basically just holds it until something says, hey, stamp what's inside of there into the page. So what we're able to do with this is not render this image. However, you still walk the contents of it using JavaScript. So we can see here, if we have a query selector for an image, then see if we have a query selector for a template tag, see if the content and the first child of that is an img. If it is, this is our image in question that we're targeting. So we can just reuse the image tag that's already in there and stamp it again. Why we might do that, useful for progressive enhancement. It's possible we have some rear rendered systems still, monoliths that are outputting their template as opposed to just being pure headless where I could just throw the data in there. Again, it's still probably better from an SEO perspective to actually have those DOM nodes there. A little bit of that is preference with the way that we roll. So then we're setting some defaults based on whether or not they're read in through properties. We also wire this up to hacks. So in hacks, we're potentially saying that we could, put this tag down and you have like a little image manipulator thing as a service. So, imagine you reference an image or you upload an image. You don't want that image to be referenced in its source, but we do still want to put up like the 3 meg image, or we want to use it in a modal user perspective. They just want to drop this stupid image there. They don't want to have to go and do all this resizing ahead of time, and they don't want to have to care that it's going into like a Drupal or Grav or something like that automatically does that conversion. They want to put the file up, get an address back, but it gets embedded into the DOM as simple-img, referencing where the file location is. That way, even though the user is getting this image from the file system, doodling real quick here, that shows up. It's actually kind of more like this, like an end around process. As in, the web server gets the image uploaded, sits there on the web server, but when another user comes by to access it, they're getting hit off of the edge network via Vercel. So that img tag sitting in the page that simple-img is dictating, while it is drawing from the server, it's going to serve up a compressed copy and not that potentially 3 meg original image. So just an easy way for the content creator to be able to do this manipulation and interface with a web API without realizing that's what they're doing. So if you're not familiar with vanilla web components, one of the reasons people get a little annoyed with them and just opt for things like lit is very verbose, right? I have to say specifically when these are changed, then run a callback. Anytime any of these parameters change, I issue this call, which I wanted to point out. So instead of, in the other examples, we have microfrontend registry dot call, right? And that call goes to @core image manipulate in this case, which binds to an address. Address is formed and it makes a post. This one for URL, let's look at what .url does. URL takes in the name of the service, which it checks for. It makes sure to generate the endpoint to the service, and then it takes the parameters and it basically creates a URL search string. So that's how I end up getting that one long string that has like the question mark and the ampersands with all the different parameters in it. Key difference between that, right, is in call, we're going to go and actually fetch the thing. Well, I have an image. I want this to be set as the source. I want it written into the DOM and be an src equals this big address. That way the user sees it when it's rendered. So instead of making a fetch, I actually am going to put that in there so they can see the thing render. So slight difference from the original one. So any of these parameters changing, as we can see here, it's going to run update converted URL. That is going to generate a new src converted. And when src converted, which is also being monitored, changes, then we're going to, this is a little performance trick I learned. It's very minor as far as its performance enhancement, but it is actually faster from what I've seen. So you create an image using JavaScript, like a class of an image, and then you set the SRC of that image right here. This is using the events of that image. So it's basically saying, it's a little weird. I don't disagree, but it's saying when this image is loaded, render it. A little weird, I know, but it doesn't actually have to print the image on the page. So one potential use case of this is you have an image that's rendered, great. Something manipulates that image to update. With what I'm showing right here, it's really fast. You don't even notice. But what's technically happening is the image is there. The properties change. It goes and makes the web request and the call, updates it in JavaScript, and then after it's successfully loaded, replaces the image in place, and then you see the new image. If you're on a much lower performance connection, you would absolutely see this happen. If I didn't do it that way and I just updated that address, every time the address changed, even if that image hasn't loaded, it takes it away. So you'd actually get like a flash of the image being gone and then reappearing. Another reason for doing this is I can use the on error event. So let's say that we send that call up and it fails in the microservice. The front end is then able to go, look, this isn't ideal, but we should probably still serve up the source. And so this will make sure the original SRC is actually rendered in the page in the event that the converted optimized SRC fails. Again, this would not be ideal. Let's say Vercel goes down, you're in some region that is blocking that for some reason, or more common, you actually witnessed this happen but didn't realize it earlier. I put in parameters that don't work together. So let's say, for example, I'm compositing images. So let's say I have a watermarked image that's this big, but my source image is actually this big. It's not going to work. You have to have a source image that's really big with a watermark that's tiny. That'll actually throw an error server side because I don't know what the size of those images are when they come in. And so the server, microservice, Lambda, it goes down. It effectively returns 500 like this didn't work, which trips the on error, which then renders the original in its place. But it's going to render it at the height and width that you put in. So you might actually have, 500 by 500 declared, but this image is actually enormous. But even in a fallback scenario, you're still going to see it rendered at the correct resolution, even if it didn't actually optimize it appropriately. So it's a cool little fallback, accounting for that service potentially failing. So when render runs, is very simple. It clears out the inner HTML of the element in question and rebuilds an image tag. And then you see it. The rest of this is all getter and setter palooza, as it says in the comments. And again, this is a reason why people are annoyed with vanilla web components. I had to then effectively map all of the attributes to properties through what you see here. Very verbose. I don't disagree. Ultra performant though, because this is a very low level API, zero dependencies. You could say, yeah, but it's dependent upon this microservice registry thing. And yes, but that saves me a ton. I actually included the bundlephobic link in the article, and it's like 2K or something to be able to get dramatically optimized images. So that's that cost reward trade-off, right? I send you 2K in order to render the image. However, I might have taken a 3 meg image and then actually rendered it to you at the correct resolution. That's a huge win. Totally worth the payload. So you can see this in question again with those links. I think this is a pretty cool use case for microservices. Really powerful having that fallback in place, right? So there's that one loaded, and there's a little tiny one. If I make this, let's say height 10, we should see it fail, which I was just describing. And in that case, it basically just smushed it and threw it there. Let's make that 100. See if we can't get it to, there we go. Okay, so now I know it worked, even though it's very small, it's hard to tell. Let's see if we make it 40. 50 isn't good, but 40 might be. There we go. Okay, so you don't see the watermarking here. Even though it's really tiny, you would see it. And that is it should be falling back successfully. There it is. Yeah, so this is hitting the original asset, but telling it to render at 40 by 100. And as you can see here, it's saying, yeah, but its actual ratio is 420 by 320. And so this is the, progressive failover, if you will. It's not really progressive enhancement. I mean, it's sort of progressive enhancement, I guess. I wouldn't normally classify it that way, but right. So if the user puts in this case, a height that's not a valid height, right? We don't fail miserably. We still do something. Um, but we can't render it the way that they were hoping to. And there we go. We see we hit the correct threshold for the watermark. If I take the watermark off, then I will be able to do these little rotations and make a little mini thumbnail at whatever quality I want with this rotation. So I hope this was helpful for you envisioning how we could actually have web services and front ends that are decoupled from pretty much everything, right? This is a web component that would work in any framework or library. It's doing something that's progressively enhancing what's there, the image tag. It's making a simple version of it, hiding all this complexity, but it's doing really advanced rotations and things via this microservice. So I think this is a very interesting design pattern of a front end, a micro front end service that is decoupled from what you're building, right? This is a reusable piece that you could reuse the web component on the front end, or you could reuse the server tech and just hit those addresses and generate your own URLs. So I hope this was of interest to you. Up next, as we move forward, we're going to get into more specific types of microservices for the application that we're building. The next tag on deck is going to be called enhanced text. And enhanced text is actually going to take text and progressively enhance it to be of higher value potentially to the user, to add in vocabulary words, or to do what's called text vitae, which is just an interesting visual trick to try and make the text more readable. So, as always, ending quote, scene.